So here we are, pure functions and immutable objects. Very quickly, 1 minute about me. My name is Victor Rentea. I'm a Java champion. I am deeply in love with simple design, refactoring, and unit testing. So much that I've created a little community of my own, which now has more than 2,500 people. And we are doing stuff on that community every single month. Even today, later on, I will have a little discussion with someone who has been studying remote pair programming for quite a while already, and he is now ready to share. And basically, there will be a Q&A discussion with Adrian Borbaca about these topics, and sharing what he discovered in this past year regarding remote programming. And then even storming, like a demonstrative session with someone from Switzerland who is doing this in various companies, and then how to design a GPA model in an expressive way and also performant. So I'm trying to do stuff every month on this community for anyone who is interested. So if that's interesting for you, do join it. It's quite something that, yeah, this is when you can contact me and you can engage with me every month. The link is on the chat. Now, I have a website on which I have my best talks, like a playlist on YouTube, then some goodies and a blog. But what I do, as I said, for a living now is trainings in various companies. These are my things that I'm really teaching every day, basically. Right today, before this conference, I did a little session on clean code at one company. Yesterday, I was in Switzerland. So this pandemic stuff, has its benefits in a sense. I couldn't have possibly ever flown to so many places. So yeah, but these are my topics in case you are interested. Yeah, this is my website. You can find my contact details in there. But enough about that. Let's turn back time for what? For 27 years. Oh my God, 27 years ago, one guy, Bertrand Meyer, had a very interesting idea. He regarded functions, he thought functions should be separated into groups, commands or queries. Now, a function that returns void, of course, you only call a function that returns void for it to produce some side effects, some changes in the universe, right? For example, to send an email, right? Or to set a field to a certain value. So this, I mean, the fact that methods returning voids do changes in the universe is not surprising anyone. But on the other hand, do you remember the times in which we used to fly? We used to fly, oh yes. And you might have searched for a flight to a certain country using, let's say, a low-cost airline. I don't want to give names here, but a low-cost airline, that's for sure. And then the same flight, when you searched for that in the morning, had some price, but when you wanted to buy the ticket later in that same afternoon, you found the price to be higher. Right? How does that feel? How does it feel to see the same flight 6 hours later for a higher price? You wouldn't expect that, do you? Or running a search, and the fact that you search for someone on, I don't know, let's say Facebook, to be persisted in 20 systems. You might not expect that. You might not expect that functions that return you values do inserts at the same time, or give you different results if you search for the same flight. So what I mean here is that functions that give us a result, most people expect that they will give us the same result every time, and they will not change anything if I run them twice. In other words, people expect functions that return values to be pure. And that's exactly what Bertrand Meyer saw 27 years ago. A function that returns results should be made pure. Now, to summarize, to point to the idea, a pure function doesn't have any side effects. So it is not allowed to change anything, not an insert in a database, no message on the queue, not even changing a field, nothing, right? No changes. The only thing that the pure function is doing is computing data based on the inputs. But even better, the result it gives you, they are the same if you give it the same inputs next time. So this means that you can't possibly rely on the current time, do you? Because you would need to be different results next time you call the function. Or even a network invocation or a select from the database can bring you different results the next time you call it. So you see, basically, this is called, by the way, referential or transparent. Basically, a pure function doesn't change anything and returns the same results from the same inputs. The best analogy you could ever find are mathematical functions, right? Nothing was persisted if you call this method twice, this function twice, and also the function returns the same results if it's given the same inputs, right? But these are pure functions, basically, that are very pleasant to work with in the end. Because you see, if you have a pure function, And by the way, pure functions are typically very fast. You know why? Because you just realize, whenever you exit the current system, whenever you even go to get some data from another system, even from a file, right? The next time you call the function, it might get back different results. Who knows what's there outside your world? So basically, the moment you realize that pure functions can't really do much networking, it's quite obvious that those functions will be very fast usually. Right? So most of the pure functions are extremely fast, just computing things like applying some business rules, doing some algorithms to compute a price. These are typically super fast. Now, if you, however, have a function which is pure, and you have a variable which is assigned to the value of that function with some 2 arguments, then if the function is pure, you can safely replace the variable everywhere with the method invocation, basically calling the method twice. And I will give you just a moment to reason. I mean, what? Yeah, I could call the method twice and nothing will break, because then there is no insert happening. And the results brought back the second time I call the function are the same as the first time I called the function, right? The definition of a pure function. So basically, pure functions are a pleasure to work with, a pleasure to refactor, and just super, super nice to work with. Now, since they don't rely on some hidden inputs or some hidden fields or some other dependencies, those pure functions are typically very, very easy to understand, because there is no temporal coupling. There is no, I mean, imagine the case in which F had to happen before G, If G depends on F running before that, it means that G must take some data which was the result of F. There is no other way in which F function can pass data to G function, and there is no other reason for having a temporal dependency between these two. So in other words, there are no hidden dependencies like you might have encountered in production code, like, oh, you have to call F and then you have to call G. Right? So these are very, very easy to understand, and also a pleasure to test. You will not need a lot of mocks, maybe even no mocks, to test a pure function, because all the inputs are in the parameters. So guess what? You give it different parameters, you practice, you rehearse a different path. Very easy, right? So pure functions are quite a thing. It is very important that you are comfortable. If you call that function, you are free to call that function as many times you want. Nothing will change if you call it once, twice, 3 times, or no time at all. Right? It's super comfortable, and it gets you in it opens a lot of possibilities for refactoring. Right? But this is quite a lot of advantages. But then you might say, oh, okay, let's make all the functions pure. And that's not that easy, because your app will have to change something, right? We'll have to persist something. We'll have to change something. Now, here's the catch. Now, imagine you have to implement a huge, complex logic. Pure functions are best used if you manage to delineate in the middle of that super complex bit of functionality a functional core, a core which is just composed of pure functions, input, output, right? And surrounding those functional cores, surrounding those pure functions that you've managed to create inside, you will have to have an imperative shell that will take this task of writing stuff out, reading from the outside world, doing all the interactions with the dirty work, right? But the idea is that in the end, the complex part of your logic should be implemented in pure functions. That's the point. However, so wherever there is business complexity, always try to model them as pure functions, passing parameters in, return values out. These are the things which need to be taken care of: time and random files, and database and API calls. I will not focus on these two first, because it's quite obvious files are not a bad thing to work with in the middle of your business logic. And time and random, although by the book make a function impure, in practice they don't give us much trouble. So it's not really a big issue in real life if you do use current time or a random call, right? In most cases. Now where the big challenge is with having with database or API calls, right? So most use cases that we implement start their lives with an initial read. You have to read some data from somewhere, maybe from the database. Now, what you can do is to read the database in the orange imperative shell, and then call F with all the necessary data, so that F doesn't need to go to the database anymore, and F can be pure. F can just compute data. Oh, and at the end of that flow, you probably need to write something back to the database, right? So that function that you called might get back some results that you will then persist to the database. That might be quite a good idea. But there will be a time in which, in the middle of a complex business rule function, full of complexity, you will have to have some intermediary read to the database, or an intermediary network call to some foreign API. If that's the case, what you can do is apply a more elaborate refactoring, which is split phase refactoring, which really means to split the functional complexity, the business rule complexity, into two pure functions, and to expose this impurity, if you want, back into the imperative shell. Pull it earlier, so that whenever you enter a workflow and you see the first function that does work, you look at it and you say, oh, okay, so I'm reading this, right? Then I'm computing this, okay, and then I'm writing this, okay, and then I'm computing this too, all right, and then I'm writing the final results. So the first picture that you see in a use case will be crystal clear. Will highlight all the places in which you interact with the outside world, and it will allow you to create these little beautiful pure functions that you can easily test with tests that almost have no mocks. Most often you can actually get to tests with no mocks, right? But you get the point, right? You expose anything which is foreign, any call to the outside world at the top level, at the first level, in the facade, if you want, or application service. But then we are left with something, basically that's the idea over here. Any complex logic you have, try to model this as pure functions. And you should always expose impurity to the surface. Let's take this. I will answer the question, but thank you after this, because it's quite stretch time. So afterwards, I will answer that. Now, one of the big challenges we have is, however, functions changing the state of objects that they are given to. And this is a very, 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 very nasty task, nasty problem in long workflows, in large code bases. And this leads us directly to immutable objects. Now, of course, when you let's say, educate yourself, when you get trained as an engineer, at the beginning of your career, you never know that the immutable objects are a thing. No one told me, at least, that, oh, I have to have as many immutable objects as possible. No one told me that. But look what happens in production. Imagine you have a very deep function, f, which runs a very critical piece of logic over there on this red line. But this line will only run in case x has the value 1. What you must do is to find where the data came from, isn't it? Well, data came from G. There you go. So it came from G. And in G, it came from H. There you go. And back in the H, it had the value x equals to 1. Perfect. But then if the data class is mutable, is changeable, you have setters, then along the way, someone might change a field. If you change a field, of course, this will return a different thing. But things get even worse, because imagine you call a method passing a reference to that data that you had, right? And imagine this is real production code with 3 functions before, 7 functions after, in between, and somewhere deep there in a corner, without anyone knowing, someone did, in a long, long winter night, a bug fix, and did that. 7 layer deep in a call stack, in a corner of your logic, someone changed the field. It can't change the field because it got the reference to the object that we are also using here. So that's very bad. But it can get even worse. You can actually call a method that you don't pass any reference to, but surprise, surprise, this method uses a reference that it kept from 5 minutes ago to that same object that you are now working on here. You can imagine how evil this is. So any method call, in theory, is a candidate to change the value of x in data. So you effectively have to scan all the code that happened before this line. Anything that ran before that line. So this is a clear moment in which it's obvious that the problem is really that these objects from here went through hundreds and hundreds, maybe thousands of lines of code. Thousands of lines of code had the opportunity to do that. And someone will do that at some point. And you will wonder at the end of that workflow, why is x equal to 1? Because you have to scan basically everything. This is life with mutable data, with setters. If we turn off this, I think only it's on your side. If you turn all this into an immutable data structure without a setter, what happens is that you don't need to concern yourselves about the setting of fields. So the next thing you do is you don't really need to trace to who you give references to that object. So you can freely send references to that object to whoever you want. Nothing will ever concern you. You only need to look at this, nothing else. Just to trace where the data was instantiated. That's the only thing you need to trace. Where does this object come from? Not whoever got the access to that reference, but who created it. Far easier in large code bases. You don't need to scan hundreds and thousands of functions. No, you just need to scan the path on which that object came from. Very easy. So the big deal with immutable objects is when some data traverses a lot of code. Imagine you are starting a workflow, a use case, right? By passing an entity as an argument to A, and A calls methods and methods and methods and methods, and somewhere deep there, someone changes a field. This is the horror story that I want to warn you about. And the alternative to doing that is, instead of propagating mutable data along a very long path, what I would recommend is just when you are about to enter the dark forest of business rules, when the last time you see the light of day, right? When you are about to enter madness, only then extract a projection out of your original entity, extract a value object, an immutable data structure, only getters. And you propagate this into all these long chain, which will allow this long chain to remain pure functions. So you pass immutable data in long workflows, and you return back immutable data out of those long workflows. You still change the field, you see, but you change it at the top level, invisible, in plain sight, in clear light of day, in there, not in a corner in the dark forest, but at the entry, right? Because any changes you do are something that you need to be very careful with, and you need to make visible. Right? This is the essential point of this talk today. Don't change stuff in there deep, but instead try to expose the change back so that it is applied at the top level. That's the essential idea of this discussion today. Now, immutable arguments, immutable return values, right? That's what we will have to do. But we've talked quite a lot about immutable objects, and I have to add one thing. I mean, we have to actually define what immutable objects are, shall we? So here we are. We probably all know that an immutable class should have the fields as final, although this is not strictly required. You could very easily drop these setters. As long as you don't have setters, the object is immutable, right? We will see. We'll come back to that. Actually, let me finish this idea right now. If you are trying to persist this with Hibernate, you will get into trouble. Mongo can handle this, but or other NoSQL, but Hibernate and final fields, they don't work nice to each other. So what I mean here is that you can actually get to persist this in a database, but you can't really have final fields over there. You just have to only expose getters and no setters. Just think about if developers don't have setters to set, then it's effectively immutable, right? And by the way, Hibernate will not care at all about your setters and getters. Hibernate reads and writes from the fields anyway, reflectively, using Java reflection. So you don't lose anything really if you just delete the setters. But that's another story. I'm a bit out of scope for today. But now, A might be immutable, we might say, but it is only deeply immutable in case B is also immutable. So only objects that you reference, a string was immutable, phew. But B, who knows? Who knows? To get true immutability, B must also be immutable. But this brings us to the next challenge. How about the list? Well, the list is mutable, isn't it? By definition, Java is an old language. Java has what, 25 years? So you see, collections in Java are mutable. So because of that, if someone gives you, just imagine the scenario, someone gives you a reference to a list, right? but then they also keep the reference to that list object. And after you construct your instance, they clear the list, .clear, on that same list that they gave you here. So effectively, if you wouldn't do that, if you would just store the reference of the list which you're given in the field, then someone keeping a reference to that list might hack your internal state. That's why you copy the list. I know that's a waste of memory, I know, and typically that's overkill. That's overkill. Typically the problem is not who created the instance, but the long workflow on which that object moves, right? The long path is the problem. This guy is the problem, not necessarily this guy. So in practice, it's not incredibly useful to defensively copy your collection, although by definition, that's the correct strategy. All right. And then in case you ever have the honor of creating an immutable object, always try to put some validation in that constructor, because that will get you to a self-validating model. You can have objects which will always be consistent, guard their own consistency. And you get this, oh, right, so you don't need to be concerned. What if someone didn't give me a not, or what if someone gave me a null S? What would you do? You will just defend against null with an if here. If there are many other ways, but this one thing. Check the constraints right there. Now, exposing a list in a getter, if you wouldn't do that, the same thing will happen. Anyone calling the getter might take the reference to that list and clear the list, killing your internal state, and you don't want that. To avoid that, however, there's a simpler solution: to wrap the list with an unmodifiable list, which is a decorator, which basically blocks all attempts to change the list content, and if you remove, add, or anything, it's just throwing exceptions at runtime. And this is quite standard way of encapsulating collections, blocking changes to internal collections, and quite a mandatory thing to do in case you are going in that domain-driven style of designing your entity. But there are other alternatives over here, one of which is to return iterable. This will scare people out. What do you mean return iterable? What is an iterable? An iterable is something that you can write a for on, right? So anyone can iterate of the collection, on that collection, but of course iterable doesn't have an add method or a remove or a clear method. It only opens the way to iterate on that. Immutable is that state-of-the-art collection management, immutable collections with Guava. Very good stuff. I will mention on a follow-up slide the POM dependency to get that. And these are very, I see this basically as the alternative to doing a modifiable list today in the teams that I train in many companies. So either a modifiable list of lists or that, of course, in case you want to protect that collection. Right? Then you will have a hash code and equal and all the fields probably. And the fun thing is that, Java 17 is just around the corner in this autumn, and Java 17 will be long-term supported. And many companies will contemplate, maybe next year, summer, autumn, will contemplate migrating to Java 17. And in Java 17, the records will be there officially supported. Records, basically, I won't show you anything in this regard, but records will just allow you to skip this, and get as hash code equals anything like that, it will be automatically generated. And you just say here public record. It's there in Java 17, not accessible for many teams for a couple of years from now, but it's there. This is the direction in which the Java language moves, right? This is the trend. We finally got immutable objects. I mean, in the language, native in the language. Good. But as usual, until Java language evolves sufficiently, what we typically have to reconcile with is most of the time Lombok. Not sure if you get this joke, but when you get tired of Java's verbosity, you generally face a decision. You become a Scala or Clojure scientist. you become a hacker. Or you start cheating Java with Lombok. It's not fair, I know. Java is an old language, we should love it, but it does have 25, 26 years. So Lombok is there to ease the way and to fix some of the things in the language. So yeah, iterator has the remove method. Yeah, indeed, you get it right. So Vlad, you're right. Iterator will, I mean, the iterator you get from the iterable does have a remove method. You get it right, indeed. But you see, exposing data, I mean, who does that? Who takes the iterator and calls remove? I mean, yeah, you are forcing it, but you're all right, practically speaking. Good. Now, so until we get to Java 17, Lombok at value is the way to go. It will also allow you to delete most of the things in here. Right? Oh, one more thing. Can immutable classes be changed? What do you mean? They are immutable. You can't really change an immutable object, but what you can do is to create a new object, right? Look here, I'm instantiating the class again using a new string, the same b and the same list. Now that's cool. What happens is that's what we call a wither. You know before you knew about getters, setters, but now these are withers. And there is actually an annotation in Lombok you can put on your class to generate these automatically, which is called @with. So yeah, withers are a way to construct a mutated value in one field, right? With s, with this new s. At which moment you get ideas. We get ideas because wait a second. So we can change them in a way. Okay, we need, however, every time you change an immutable object, you have to return it back, right? So if you change x, you have to return the data back in the return, because that's the way it works. You can't really change this instance, so the only way you are left with is to return it back. And then look what someone someone who didn't got the point, look what someone could do. Someone could subsequently change the x field, the y field, and the z field, calling 3 different methods, one after the other, every time passing the data to the next method, chaining them. And the garbage is still there. You will still be asking yourself, who the heck changed field x? You have to trace where that instance came from. Aha, it was you. I'm not sure if you get this already now. It's out of context, but if you always return back the object, you can effectively write the same kind of code in the end. But this is a bad practice. Taking an immutable object in and returning the same type back is only acceptable if you do it once. And in some extent, what you are not really following is the immutable mindset. Whenever you do this kind of code, you are reassigning the variable, aren't you? You are reassigning the variable to the new value and so on and so on. One brutal solution is to mark the variables as final. So what I want to say here is that it's not just enough to mark the fields as finally or make your data structures immutable. You have to adopt the immutable mindset completely, which means you should not be reassigning variables or parameters at all, at any moment, right? So that's the true mindset, right? But that is a brutal solution. The real problem we are facing over here is the fact that we have a very large object. Probably this class has, I don't know, 8 or 10 fields. Although I've seen and worked comfortably with mutable objects with 30 fields, mutable with getters and setters. Having immutable objects with 30 fields is virtually impossible. You can't survive with an immutable object of 30 fields. You will have to change some of that at some point. Then what would you do? Would you clone the 29 fields? And what the heck are you doing? Something is wrong. The reality is that with immutable objects, you really can't have extremely large immutable objects. Any immutable object larger than 5 or 7 fields is dubious. It's something strange. So what you should be thinking to do here is to create maybe a method which returns the XYZ, then a new type, a new data structure, which is then assigned to the data. So you see what I mean? I just created a new data structure, XYZ class. So decompose immutable objects into smaller ones, right? Okay. One last thing regarding changing collections. You know that you can change collections. Let me show you the horror story here. Just enjoy this. You are taking an array as a parameter and you change, but who takes arrays as a parameter, right? But we can easily take a list. And here we are changing the list. Right? It's useless to say, isn't it, that you should not change the collection, you should not mutate. Don't ever mutate your collections, right? Never create, I mean, not clone, but create new projections, like filters, like stream filter, collect to list, stream filter map, collect to set, create new collections. But if you want brutal and actually the state-of-the-art solution in this regard, this is Guava collections, like this, immutable set, immutable list. Very good stuff used by my best clients, basically, that are playing with immutability. This is a different set of collection objects from Google, basically. Very good stuff you should try if you are interested into this. All right, so immutability is good. Why? Because it's easier to trace where the thing happened. Then it's also trade safe because you can't change them in multi. You can't really change them. Okay, so you can give those references to whoever you want. So they are very good, very good. But then you might want to try to make all your objects immutable. And I must warn you, this is overkill. Doing the entirety, converting all your data objects to immutable is not a goal. It's actually over-design, overkill. So the best, I mean, the main question is, should my entities, my hibernate entities, my persistent entities, should those be made immutable? No. Your root entities and aggregates, the thing that you persist, should remain mutable with setters. Right? But then you should extract little parts of those objects into smaller value objects, which are immutable, while you leave the root with having setters. So let me put you in a picture. The root entity, let's imagine customer, which will have getters, setters, everything. But then there might be some part of that customer, let's name it full name, that you want to keep as an immutable structure, which just first name and last name. Okay, this would not have any setters, although the customer entity will have a set full name, for example, in there somewhere. So the root entity should remain mutable in the vast majority of the projects, but the smaller components could be made immutable. So that's a goal for you, to continuously break out those little objects out of the root entity. Right? And the keyword you can do that with an ORM, with an Hibernate or whatever GPA implementation, is the keyword is embeddable. Google this annotation. This is the best feature that no one really uses correctly from Hibernate. Right. But besides things that you put like smaller parts of entities, there are also these butterflies, these little objects, these little small types that are there in runtime, just used for throughout a flow. Like we tried to sketch a while ago when we, in this style, this little object that you created over here to pass in that long flow, this should always be made immutable. So whatever structure never gets persisted should be made immutable. So non-persistent runtime objects should be made immutable as long as you write heavy logic on. Pay attention. There are those data transfer objects that come from and go to JSON or XML or whatever. Those should not be made immutable. It's overkill. It's overkill. Because honestly, in the end, you don't write much logic, or at least you shouldn't write a lot of logic using DTOs of your API model. So instead, what you do, you convert the DTOs into value objects that you work with in the middle of your business logic, of your core logic. Those internal little objects should be immutable, not the boundary ones. Those are boring. Those are stupid, right? So the big deal, again, is when immutable objects travel lots of code. Any piece of data which moves along hundreds or thousands of lines of code should always be immutable. Haha. Will this hurt us? Well, most good developers out there are always concerned about performance. It's something in your education which makes us consider that a true software engineer will always write performant code. Yeah, but with performance, my goal is the same. Measure it. Measure it. Wait. What about the classes generated by CXF? They have setters. I don't care about those classes. DK. The classes that are the boundary objects, the data transfer objects, if generated from VSDL or from YAML or from open client, I don't know. I don't care. I don't want them to be immutable. You can leave them immutable. Any advantages of immutable set over set of? The magic is in the copying of that collection. So immutable set is more efficient when it comes to cloning collections. It's quite tricky to explain in short, but yeah, it's better. And also immutable set will spread basically. Set of, at some point you will create, plus the fact that set of, you have to have a fixed number of values, right? If you construct a set from a collection, that final set will be immutable. Or if you extract, or if you collect a set, that final set will be mutable. So set of only works for fixed number of items, like constants or something like that. Not very, correct me if I'm wrong, but I'm not sure what you mean here. So, however, despite the fact that performance will not hit you, you shouldn't take my word for that. You should measure it yourself, right? But the point is, the eviction of those instances that got created along the way is super fast because those objects are evicted in the minor garbage collection cycle incredibly fast. Microseconds it takes for GC to evict those. It's not important really. But indeed, if you do trash and you create millions and millions of instances every single second, then indeed it's not a very good idea to use immutable objects, of course. Then if you get to clone a lot of collections, right? You have a collection, let me add this new element. Well, if you add a new element, then you have to first clone the original collection and then add your new element, don't you? So if you do that a lot, that will kill GC because you will do a lot of memory allocation over there, killing your memory basically. Another thing to keep in mind, the root entities should not be made immutable, nor should the DTOs that you also mentioned, those VSDL or JSON objects that are generated. Those don't deserve the honor of being made immutable. Another perspective from the same idea, if you have some trivial logic to write, imagine you have a super boring use case or endpoint which says activate customer, which makes the customer active equals true. Incredible, right? And plus some auditing and some rule and some security checks. Okay. So this is a trivial logic. It doesn't worth to make to employ immutability in such a trivial use case. So basically, immutability, you need to keep it as a tool for the most complex parts of your logic. Whenever there is business rules, complex, creepy business rules, that's where you want to pull out the big guns and throw immutability at it. So what will be the takeaways from all this? Whenever there is complex logic, like price computations, promotion algorithms, what else? Decisions like security decisions that are very complex sometimes with vetoing and all sorts of complex stuff. Whenever there is complex logic that you have a hard time understanding, and also that is hard to express in the requirements and hard to get, always think of pure functions and immutable objects, right? Because these are easier to test, right? Easier to understand. There are no hidden dependencies. You can't ever find a pure function telling, oh, wait a second, I will go to the database to fetch more data. That's not a pure function anymore, right? So you get more comfort in understanding what that function is really doing. Now, most of our use cases, don't get sad, but most of our use cases are quite dumb, are they? So don't feel somehow awkward that you don't have much logic to extract. But whenever there is complex, a lot of branching around with many ifs and many fors and boundary conditions, those should be made pure if possible. Okay. Now, the idea is functional core imperative shell, this segregation, which, by the way, is one of the most advanced design principles today. Having this core central part composed only of pure functions surrounding by the shell that interacts with the outside world. Also extremely good for testing, I mentioned it already. And then pull anything which is impure, like remote or database calls, to the top level, to the surface, right? And then never think again that we should just change the field in there. Never, ever. If there's something to take from this talk, give up that idea of, oh, let's change that thing deep there because, yeah, it's a bug fix. No, compute and return. And then in plain sight, reassign the value. That's what will get your further debugging session much easier and less bugs. Then immutability is a mindset. Remember that guy. He didn't really understand what immutability is. He was just wait and then return, wait and return. You have to have a mindset. You have to not reassign variables. Don't change the arguments that you are given. Don't change the variables. Don't reassign or don't change the collections that you manipulate. Right? You should not change stuff. Instead, compute and redo and recreate basically. And what I want you to make immutable again is data which moves in long workflows, as well as persistent bits of your small parts, several fields, grouping of persisting data. And you can extract them as embeddables, and you can reference them from your entities. So if I were to summarize all this in a single idea, please take this out. Stop changing things deep in a very complex place, but instead compute and return. Now, that's a mindset. Don't change, but compute and return. And I think it's among the very extremely few times that I fit the time frame that I'm given. So, but I have one question to answer. One second.
Yes, you did it.
Yes, it's incredible.
You also took up questions along the way.
I've seen them. One question, it remained unopened. I can paste the question for everyone to see. Related to exposing database in HTTP calls, I guess validation logic is a good candidate for extracting into pure function. Yeah, yes. Validation logic is something that, although not particularly complex most of the time, sometimes it pays to extract, perhaps, especially when the validation is bound to the current state, especially when validation rules change according to what is the current status of that entity. Then it becomes tricky. For example, a record that was submitted must not have first name null, but you could tolerate a record with a null first name in case it's in the draft state. In case validation is complex, it could very well be implemented like that. But of course, never forget about not null from JavaX validation. I mean, that's clearly the king in this regard for simple validations. Yes. Just check last question. Let's see. Was there any VSDL? No, I think I've answered all of them. Right. Good. Now, any other thoughts from your side, or maybe what?
I need to digest, Victor. I mean, I have to confess, I need to replay it, a bit slower, and then take the idea. And but I very much enjoyed that. So
you still need some time to get into the immutable mindset.
Yes.
Yeah, I need that. Yeah.
All right. It was a complex topic, I know, and it's one of the most fine-grained design discussions I have during my trainings. It's hard, really. Really is hard. No one talks to you about immutability during your education at any moment in time. But then you realize only after hard bugs and long nights of debugging, it's true value.
I can relate to that. So I learned about this only after I got my first job. So not in school, definitely. And yeah, it's a thing because you see also other languages that add more and more features to help you get immutable objects.
For example, in Kotlin, they have data classes, which are immutable by definition, just our record from Java 17 in Scala, which is Kotlin classes. This is Kotlin. In Scala, they have case classes from a long time ago, which do exactly that. So Java is one of the last to the party, But back in '95, no one thought about immutability, really. I mean, just what that? Who needs that? Let's be efficient. That was the trademark of that age. Now you realize, in face of large complexity, that this really pays off.
Right. There's also I'm also afraid of the downside. Maybe at some point somebody wants to make everything immutable in their code, and that's also a pitfall.
That's another bad extreme, because that's not the point. Some places don't deserve immutability, and immutability has a price to pay, very high price to pay. Sometimes you have to create many new little classes, like I've suggested, those value objects. You have to create a lot of new classes so that you can return a new thing, which is a thing, which with two fields. You have to create dozens of classes sometimes if you apply it in many places. Cool.
Exactly. Well, thanks a lot for the talk, Victor.
Thank you for inviting me.
Always fun,
as usual.
Always energetic.
Always fun, of course.
And insightful. Right?
Yeah.
Soren, still in? Are you getting closer to the mindset?
Yeah. Step by step. I promise. Immutability is my next target.
To make yourself a statue. But guys, by the way, thanks a lot for all this effort. I know how hard this is. Thanks a lot in the name of the community for what you're doing. Keep up the good work.
But thanks. For that, I have to recreate myself, right? So I'm still processing.
Okay, to clone yourself, you have to.
I have to recreate myself.
Yes, the copy constructor. You need the copy constructor to create a new. Yes.
That's what the world needs. Two of you.
Oh my God. Okay.
Yes. I will drink to that. Two of Florin.
All right, Victor. Until next time, then. Hope to meet you again soon.
Have a nice day. Thank you. Bye.